In this video, I use the graph from last time in lecture 19, relating the marginal product and the average product, to derive the cost graph that will be the foundation for supply. Average variable cost is variable costs divided by quantity. Now, we can sort of manipulate this a bit to get a relationship with average product. So that's where we're going. Now, in the short run, remember that capital is fixed, at least the way we're thinking about this setup. So variable costs are really labor costs. And quantity is just quantity. Now I'm going to do a trick that mathematicians love to do. I'm going to divide both top and bottom by labor. That's like multiplying by 1. It doesn't change what this is, so we get to put the equal sign there. So let's just think about what these things are. This is dollar per unit of labor. That's just the wage. And this is output per unit of labor. Well, that's just our average product. And so now we have a relationship between average variable cost and average product. All we need to know is the wage. We can also derive an expression for marginal costs. And it turns out that we can just use the same form as what we had for average variable costs, except for what we're going to think about is it's going to be the wage divided by the marginal product of labor. The marginal cost is the cost of producing one more unit of output. That we need to use 2 worker hours to produce 1 unit of output. So 2 worker hours to produce 1 unit of output, that would mean that our marginal product of labor, well, that would just be 1/2. We need 2 workers to get 1 unit of output. That means that each additional worker produces 1/2 of a unit of output. Then if we have to pay each of those workers $10 per hour, say that's their wage, $10 per hour, how much does it cost to produce that last unit of output? 2 workers, $10 an hour. It's got to be $20, right? Well, it turns out 10 divided by 1/2, that gives us the right answer. So let's go ahead and think about what these equations imply for the shape of average variable cost and marginal cost. Well, notice that both of these are inverted U-shaped. Another way of looking at the inverted U-shape is that for low amounts of labor, marginal product is low. For intermediate amounts of labor, marginal product is high. And for high amounts of labor, marginal product is low. Same goes for average product. So notice that with this equation, what we have is we have those numbers that we're inputting here are in the denominator. And what will happen is something that looks like this, because it's in the denominator, and we're dividing the same number by these numbers, we're going to get something that looks like this. Notice that when we have a low labor input and we divide that into the wage, that's going to give us a relatively high number. When we have an intermediate labor input and it gives us a high average product or marginal product, that's going to give us a low number because we're dividing by a bigger number. And similarly, we're up here at a higher, when we increase labor, what we get is we get a smaller number. We divide by the smaller number, and it's the same wage, so we end up increasing back up again. So what we'll see is that this average product curve here turns into an average variable cost curve here. And it's got this U-shape. Inverted U turns into a U-shape. And the marginal product curve turns into a marginal cost curve, again with a U-shape. And notice, just like the last time, when marginal cost is below the average variable cost is decreasing. It hits a minimum right where they intersect, and then it increases after that because marginal cost is higher than the average variable cost. So then what happens if we want to know our average total cost? Our average total cost is just total cost divided by quantity. Well, that's just going to be our variable cost plus fixed costs divided by quantity. And you can see that right in there, we have a average variable cost just sitting in there waiting to be exploited. That's average variable costs, and then this other part is fixed costs plus fixed costs divided by quantity. So there's our equation for average cost that relates average variable costs, fixed costs, and our quantity. So once we have this graph, we can just learn something about our fixed costs, and then we're able to draw the entire graph. Now, one thing that you'll notice is that this contribution here, what some call average fixed costs, declines as Q increases. That's because the numerator is a constant, but the denominator increases as we go along this Q axis. So notice that what will happen here is there will be a big difference here, but a small difference here. Notice also that average costs is an average, and so we'll have the same relationship with this marginal cost curve. So what we'll have is we'll have the average cost is asymptotically approaching the average variable cost. As Q increases, average cost and average variable cost become indistinguishable because those fixed costs get averaged over a larger quantity. And what happens is the average cost, just like the average variable cost, average cost intersects marginal cost at its minimum. Marginal cost goes right through the minimum of both average cost curves. So this is our cost curve graph, and this is some of the theory that underlies the way we think about our cost curve graph. This is the production side here, but through these equations, this one here, average variable cost, this one here, marginal cost, and this one here relates average costs, average variable costs, and fixed costs. We can totally construct our cost curve graph from information on the short-run production. And so this graph will be very important because it turns out that it gives us a really convenient way to see where supply curves come in. And this is going to be fundamental to understanding supply curves, industry competition, and we'll go directly to this graph when we start thinking about monopolies and more complicated models.